the fifth lab of Upadhyay Coding Lab. And in this lab we'll talk about the exception handling in Java. As the term suggests, exceptions, right? The exception handling means being able to handle the exceptional cases in your software. So let's say your software is a e-commerce website and you let your users be able to purchase the items. So that's the feature you want to provide. And in success scenarios, right, user will be able to purchase the item, all good. But there could be cases where, let's say, user makes a purchase, but for some reason that item is out of stock. And what do you do in that case? Right, so that's the exceptional case. Do you want to tell the user to try again, or maybe even if you don't have the stock available at the moment, you might be able to fulfill it from another store, so you recover from that. So in Java, the exceptions are classified as something that can be recovered and something that cannot be recovered. The ones that can be recovered, like I said, could be the item is out of stock, but maybe you can fulfill the item from another store, and there is no one definite answer, right? It depends on how you handle your exceptions. And the ones that cannot be recovered could be the user makes the purchase but they don't provide their user information. That means we don't know who is purchasing, so there is no way to recover but to tell the user, hey, you are giving us the bad information. And there are also another case of the unrecoverable errors that Java doesn't call exceptions, but the errors, which are like the exceptional exceptions. And those could be when you're trying to load some information into the heap of Java, but the memory size is bigger than the heap size of Java, right? That means you cannot even fit the data into the heap of Java. So the JVM will just crash with out of memory error. So these kind of exceptional exceptions or abnormal conditions are called errors in Java that you cannot recover from. The other case could be if you are running recursion, and as you know, recursion must have a base condition that determines when to stop the recursion. But if you don't have the base condition, your recursion will keep going forever, and that recursion will keep filling the stack size, and at certain point it will exceed the stack size defined by Java, and just like the out of memory, it will be stack overflow. So now let's see some examples. I'm in my IntelliJ and I'm going to create a new package called exception, and Java has throwable that captures all the recoverable and unrecoverable exceptions. And under throwable, like I said, it has exception. As you can see, exception extends throwable, and it also has runtime exception, which are the non-recoverable. As you can read the definition of exception, it says that the class exception and its subclasses are a form of throwable that indicates condition that a reasonable application might want to catch, right? Because you can recover. But runtime exceptions is a superclass of those exceptions that can be thrown during normal operation of the JVM. And runtime exceptions and its subclasses are unchecked exceptions. So let's start with the unchecked exceptions. If you are trying to do the division, let's say 20 by 10. Okay, and that is going to be 2. But what if your denominator is 0? You will get the division error. You can see that this throws the arithmetic exception, and arithmetic is a runtime exception because your input is bad and you are getting the exception and there is no way to recover, right? So this is the unchecked exception that happens at the runtime because of the invalid input. I have a method that is helping me purchase an item. And the method takes the customer ID and the item that I want to purchase, and if it succeeds it will return the message, success message. What if the customer ID is empty? We cannot do anything, right? If the customer ID is empty, who do we charge against? So I have to add a check if the customer ID equals to null or customer ID is empty. I will throw an exception, throw new purchase unchecked exception. I don't have that exception yet, but I'll define that exception, and with the error the customer ID is empty. Alright, so now let's define the unchecked exception called class purchase unchecked exception. And since this is unchecked, I will have to extend runtime exception, and I want to add the error code. I have to define the constructor that takes the error code and the error message. All the exceptions in Java should have the error message, but I'm adding error code as well. And I first pass the error message to my runtime exception, then I fill in the error code as the one that is passed. So the error code could be, this is the customer error, right? So I'll just call it invalid request. But if the customer ID is good, then I'll make the purchase for the user and return a success message. Call that method customer ID. I'll pass in empty, and item ID Samsung TV. Alright, so if I run it, it will throw the runtime exception, and I should see that in the stack trace. Right, you can see that the main thread exited with the error customer ID is empty, and you can see the stack trace that main line number 22, that's where we call the purchase, and that called purchase, and it threw the exception at line number 15. You can see the line number 15, and this is called the stack trace that gives you all the information where the exception is arising from. If you want, you can still try to recover from the unchecked exception. Like you can catch the unchecked exception. This is how you try to recover from the exception. And for now, you can just log the information. And for logging, Java has Java util logger. So I define the logger and logger can have multiple logging labels like info, debug, or severe. Since this is the error, I want to track it as severe error, and then the message error occur while purchasing, and the third argument would be the whole stack. You see the log with the date that it happened and the message error and the stack trace. Now let's do the checked exception. So checked exceptions are when you want to recover from the exceptional cases, and as I said, it could be when you try to make a purchase but the item is not in the stock and you still want to fulfill it from another store where it is available. It's not available in the stock, so I want to throw a new checked exception called item not in stock, and there is no return for the exception, by the way. So for the exceptions I don't return, I throw the exception. It takes a message okay, let's define the checked exception. And that extends the exception or throwable. It could be either. And I need a constructor that takes the message and that also should take the stack trace. Alright, we don't have the stack trace for this one, so I'm just now the difference is that, as you noticed in the unchecked exception, since there is nothing to recover, the method label, method signature doesn't have to change, but for the checked exception you have to specify that the method will be throwing exception in the signature itself, so it becomes throws item not found exception. Alright, so now I'm calling that method from my main application, and I have the customer ID in this case, and I'm buying Samsung TV. You can see here, since this is a checked exception, the compiler knows that this needs to be recovered, so it complains if I don't have the recovery. It complains saying that unhandled exception, so I catch the item not in stock exception. Okay, and in the recovery process, I don't have the whole code right now, but in the recovery process, I should try to purchase this item from the store where the item is available, so I can do the recovery process here. You can see that it logs item not in stock with the stack trace. And Java also has a finally block where you could clean up if there is anything that you want to clean up. And we don't have anything to clean up, but there could be a case. For example, you might be reading a file and you should clean up the resource that you use to read the file or write to the file in the finally block. So that's pretty much all about the exception handling. And some of the key things that you need to keep in mind is you define the checked exceptions when you want the client to recover from the exception. You define the unchecked exception when there is nothing that the client can do to recover, and always log the exception so that it is helpful when the problem happens in the system, right? You know what happened, what failed, what caused the failure. You have that information available. One more thing that you should do for the exceptions is track this information in your monitoring dashboard as well. So that way you capture the exceptions, how many times it happens in your system, how often it happens, and based on that threshold you can alert or alarm yourself or your team. That way you can quickly mitigate the problem. I hope this was helpful, and if you have any question about anything, please let me know. Have a good one.